Hello everyone, welcome back to the course. In this lecture, first I am telling you about visualizations and simple metrics. A rule of thumb for data science deliverables in this: if there is not a picture, then you are doing it wrong. Typically, a good analytics project starts with exploratory visualizations that help you develop hypotheses and get a feel for the data, and it ends with carefully manicured figures that make the final results visually obvious. The actual number crunching is hidden in the middle, sometimes almost as an aside. I have had a number of projects where there was never even my actual machine learning. People needed to know whether there was single in the data and which directions were most promising for further work. And graphics showed that more clearly than a number ever could. This fact is very underappreciated outside of the data analysis community. Many people think of data scientists as numerical badasses working black magic from a command line, but that is just not the way the human brain processes data, generates hypotheses, or develops familiarity when an area. Picture or plants AC for everything expected the last steps of statistically validating results. Now a note on Python's visualization tool. The main visualization tool for Python is a library called Matplotlib. While Matplotlib is powerful and flexible, it is probably the weakest link in Python's technical stack. The graphs can be a bit cartoonish in some ways, the syntax is non-intuitive, and the interactivity leaves something to be desired. Most of the appearance issue can be fixed by tweaking a graphics configuration, but the default settings are not great. Now example code. To illustrate the visualization technique, we will apply them to the famous iris dataset, which you may have seen in a statistic textbook. It describes physical measurements taken of follower specimen drawn from 3 different species of iris. There are 150 data points, 50 from each species, and each data point gives the length and width of the petals and sepals. Now pie chart. Pie. Pity the poor pie chart. I feel like I never see it used in serious application, almost as if it is looked down on as being too simple. But pie charts are really one of the clearest way to present data, and I recommended using them whenever they are applicable. Technically, everything you get from a pie chart you could get equally well from looking a list of numbers. But making sense of number requires cognitive effort and attention. On the other hand, lower level neutral circuit makes immediate sense of pie chart. This is perhaps the clearest illustration of the guiding principle behind all visualizations. It is not about conveying information but about conveying it in a way that the human brain will understand and care about. Now bar chart. The same information is in a pie chart could equally will be conveyed in a bar chart. In this particular case, it is actually a much more sensible visualization since we are interested in the relative sizes of the different followers rather than how big a slice of the follower pie they each take up. The font size optional argument control how big a piece of font is. It is usually too small by default. Now histogram. Histogram are probably my personal favorite visualization tool, partly because it seems like they usually contain something interesting. There are often distinct bumps in the histogram which might correspond to several distinct classes of real world entities. And that's it for the lecture. Thank you for watching.